Next speakers is a duo act of Danielle Coke and Joanne Turnbull from Massey University in Auckland. And Danielle is going to talk on, it's about the ABATE project. If you've not heard of this, they will explain. But Danielle will talk on about the ABATE project regarding soil samples and phage finding. It's a progress report. This is to do with AFB. And Joanne will talk on a complementary host phage hunt in the ABATE project. So Danielle and Joanne, welcome.
Hi there, I'm Danielle and this is Joe, and we're here from Massey University, and then we're here to present our project From Soil to Solution, isolating bacteriophages from the environment to combat American foul brood. So firstly, we'll do just a little bit of background, because I know most of you here already are experts on AFB. So AFB is the most serious disease that infects honeybees today. It's caused by the bacterium, which is gram-positive, and it's Bacillus larvae. And Bacillus larvae comes both in a spore form and a vegetative form. Now, it's the spore form that actually causes the infection, and they infect the bees at the larval stage. As you all know, infected hives must be destroyed immediately. So this is by depopulation and then burning of the hives. Now, this, of course, is not ideal. So the other part of my project, which is bacteriophages. So what are bacteriophages? So they were first discovered in the early 1900s. They are used to combat bacteria in an application known as phage therapy. They're self-propagating viruses that can only infect bacteria. And there's an estimated 10 to the 31 globally. So to put that into perspective, that's approximately 1 trillion phages for every grain of sand in the world. So bacteriophages, how they work is they attach to bacteria, they then inject their DNA into that bacteria, they then take over the bacteria and use it to replicate itself. Once they finish replicating and they've put themselves together, they then break out of the bacterial cell, killing it in the process. So as you can see, they're very effective at killing bacteria. So phages, how are they used? So at the moment, currently, they are used for bacterial crop diseases. The FDA in the US has given generally recognised as safe status to approximately 10 different phage cocktails. Cocktails such as Epiphages used in Hungary for fire blight, and also Biolice used in the UK for soft rot. Now, phage therapy isn't only used in crops and things like that, it's also used against human bacterial infections. So I'm just going to tell you one short story that it has been used in for humans. So that story is called The Perfect Predator. So it was a husband and wife, Tom and Stephanie. They're both PhD qualified researchers. They were vacationing in Egypt when Tom was hit with a stomach bug. They thought just a normal course of antibiotics would fix this, but unfortunately it didn't. Tom ended up in a coma in Egypt. He was then medevaced back to the United States, where they found that he had inside him the most dangerous antibiotic-resistant bacteria in the world. There was no antibiotic that was going to help him. Tom was in a coma and the prognosis was not good. Stephanie, already being a researcher, knew about phages. She convinced his doctors to try bacteriophages as a last-ditch attempt. She contacted the phage community and found phages that were relevant to the bacteria that was inside Tom, and they used this on him. Thankfully, it worked. And within days, Tom was out of his coma and he made a full recovery. Now, this is Tom and Stephanie in these pictures during his recovery and afterwards. So as you can see, phages are an amazing thing. So with this heartwarming story, we'll go back to phages for AFB. So there has been previous work undertaken in the United States. So there was some work undertaken at the Brigham Young University in Utah. And so what they did was they had an apiary that had 11 beehives in it. One of the hives became infected with AFB just from naturally. They then took the remaining 10 healthy hives and split them into two groups. One was a spray-treated mock set, and the other was spray-treated with a phage cocktail. They came back after 4 weeks to check these hives, and what they found was 80% of the mock-treated hives were sick with AFB, whereas only 0% of the phage-treated hives were sick with AFB. And this showed to us that it is possible to protect a hive from AFB using bacteriophages. There was some further work that was undertaken at the University of Nevada in Las Vegas, and they also made up these phage cocktails. And so as you can see here in this graph, so these are all different bacterial isolates of Penobacillus larvae, and then down this side are all the different phages that they did isolate. And they tested every single one of those phages against all the bacterial isolates that they had, and they found that a lot of phages were able to infect those bacterial isolates. They took the 7 best phages, they were able to infect the most bacterial isolates, and they put that together in a phage cocktail, and they used that in lab testing to be able to protect bee larvae from AFB. So the purpose of this phage cocktail is if we're using many different phages, we can hopefully stop the resistance. So even if a bacterial strain becomes resistant to one phage, there's potentially 6 other phages within that cocktail that can then go on and continue killing that bacteria. We're hoping to also have further phages that we can keep in backup so we can start changing and adding them to the cocktail at a later date. So, Penobacillus larvae strains here in New Zealand. So if we wanted to isolate phages, we first of all needed to have Penobacillus larvae to isolate the phages on. Unfortunately, all strain collections in New Zealand have been destroyed, so we had to start from scratch. We've been working in collaboration with Assure Quality, who's been sending us suspect brood frames, and from those suspect brood frames, we've been able to isolate Penobacillus larvae to use in our studies. So far, we've isolated 8 positive Penobacillus larvae strains, and that's what we've been using so far. Then we had to conduct our phage hunt. So far we have processed 395 soil samples, and most of those soil samples have come from beekeepers potentially in this audience, or beekeepers are still out there working today. So this is a citizen science approach where we've been getting help from beekeepers around New Zealand to get these soil samples. And so as you can see from the map, we've gotten soil samples from the tip of the North Island all the way down to the bottom of the South Island. How do we look for phages? So we take that soil that's been sent to us by beekeepers, we flood it with some solution, we then filter that solution so that we're only taking out the tiniest particles. These particles are smaller than bacteria. We're then putting this solution onto the Penobacillus larvae, and we're looking for cell death, as you can see in this image here. This is what we would call a plaque, and that's clearing of the bacterial lawn because of the phages. So to date, we've been working on this project for a year now, and to date we have found 17 positives. So we found phages within 17 of our soil samples. These have come from locations around New Zealand, and on this map they're the ones in red. And most of these samples have actually been collected from healthy hives without AFB. This is an image of 3 of our different phages on 3 of our different bacterial isolates, and this is, like I said, a plaque, and so this is what it looks like when it clears a whole spot of bacteria on our plates, and so that's what it looks like when we're trying to find the phages, and that's how we know that it is killing the bacteria. Now, phages are tiny; they're much smaller than bacteria, but thankfully we do have ways of being able to see these. So we've been using electron microscopy, and so that's when we take a sample and we fire an electron beam at it to be able to see it. And so these are images of some of the phages that we have found so far. So these are 3 of our different phages, and as you can see, they have got this one. They've got quite a long, we call that a prolate head, and then this is its tail, or as some people like to refer to them, corn dogs. And so these are the types of phages that we have found so far that are able to kill Penobacillus larvae or AFB. Some further work that we have been doing is we've been testing the host ranges of our phages. So this is similar to the work that was done in the at one of the universities in America, where we're testing all the phages that we have isolated, so that's down this side, against the bacterial isolates that we do have. Right now we're seeing 2 distinct host infection patterns where our phages are able to either infect 6 of our 8 strains or slightly less. But there are 2 bacterial isolates that we have so far that haven't been able to be infected by any of our phages. So we are continuing our phage hunt until we do find the phages to be able to kill every single bacterial isolate that we do find here in New Zealand. So, my future directions. We are going to sequence our phages. So we need to first of all extract DNA out of them, get that DNA sequenced. We'll continue testing our phages, so we'll continue isolating phages, looking for phages, and testing these phages on as many different strains of Pinebacillus larvae as possible. We then will try and produce one of these safe bacteriophage cocktails of the phages the most robust phages that are able to kill the most bacterial isolates. And then once we have that phage cocktail, we're going to do some in-lab testing to make sure that we can protect our bee larvae from Pinebacillus larvae. Now I'm going to pass you over to Jo, who is also working on this project, but just in a slightly different way.
Hi everyone. My name's Jo. I'm going to be speaking to you very briefly because I have just recently started my master's project with Massey. My part in the ABATE project revolves around complementary hosts. So in our case, these are non-pathogenic bacteria that are related to Pinebacillus larvae. Different phages will have different ranges of host specificity. So finding a phage that will infect these relatives of Pinebacillus larvae might help us to kind of add to our arsenal in developing a phage cocktail to prevent AFB infection. I started this year by receiving and beginning to cultivate 5 bacterial species related to Pinebacillus larvae. One of these, Pinebacillus ash et al. NZ, it hasn't been entirely classified yet, was selected to begin my phage hunt. And the reason that we chose this was because its ideal growth conditions are easily reproducible in our lab. So far, Pinebacillus ash NZ has been used to process almost 80 samples. We haven't found a phage for that host yet, unfortunately, so we do need more samples. If you'd like to know more or grab some sample packs from us and help us with, both Danielle and I, with our phage hunts, come check out my poster and have a chat to Danielle or I.
So as Jo was saying, how can you help? So we still need to find more phages. We need to find those phages to kill those bacterial isolates that we haven't found phages for. So we need more soil samples or samples of bee debris. I also have a poster, and my poster looks exactly the same as this. If you want to come and see us at our posters in the break, I do have sample packs that I can give to you to take home so that you can take samples. They come with a prepaid envelope so you can send those samples back to me. That would be most helpful because I need to process more samples to get more phages. And the added bonus, if we do find a phage in your soil sample, you get to name it. So it will be published in a science publication, and it will have the name that you have chosen within reason. So just some acknowledgements. So I'd like to acknowledge Heather Hendrickson. So she is our supervisor. She wasn't able to be here today or at this conference because she's currently in America. All of our colleagues in the Hendrickson lab, we have received funding from AgMart and the Sustainable Farming Fund. And we've had cooperation from Assure Quality and the AFB PMP, and also a special thanks to Farmlands Cooperative. If you go to their stall, you will see some awesome bags, and some of that goes towards our research. So thank you very much. Any questions?
Use the microphone, please. Can't hear you.
How much traction do you think you'll get to be able to use a phage to treat AFB if the standard is destruction. I mean, as a beekeeper, it would be great to find a solution, but would there be traction to change the current law to use a treatment over destruction?
So it's not a treatment. This would definitely not be used as a treatment because the laws specifically state that we are not allowed to treat AFB. This will be used as a protective measure. So this would be sprayed onto hives or put into hives before you would get an AFB infection, and it would be used like a vaccination. So we would not be treating hives because that's not allowed, and we're not looking to change that at all. We're looking to protect hives to stop AFB infection in the first place.
If you're successful in producing this vaccination, would it need to be repeated regularly, or is it just what sort of time period would you need to repeat it?
It's a really good question. I don't have numbers on that yet, and that's all to do with those lab tests that we would be doing. Once we've found the phages that we've put together a cocktail, we'll be doing a lot of in-lab testing to look at how effective it is, how long it lasts for, all of these kind of things, so that we would be able to make those recommendations as how often you would need to treat your hives. But right now I don't have a number on that, sorry. Thank you.
Okay, well, thank you very much, Joanne.
Thank you.
And Danielle.
Oh, thank you so much.
Ronan, do you have a question?
Yeah. Just like vaccination, I know it's a big subject or whatever, but what are the chances of mutation and actually making AFB stronger by doing that sort of stuff, mutating it and turning into something even more powerful? Is there a chance of that? Or? Thanks.
The mutations that you would get would be resistance to your phages, and that's why we'd use the phage cocktail approach. So even if one bacterial strain did become resistant to one of the phages, you would have many other phages within your cocktail to continue killing them. So I don't think you'd get some kind of super AFB. They would just gain resistance to one type of the phage.